Okay, so today we're going to look at the and or rules in probability. Now, as you can see, there's a student, Elo, that everyone's going to be able to apply the and or rules to GCSE style questions. Now, our key points are, firstly, probabilities can be written as decimals, fractions or percentages. That's something that you would have done at primary school or in year 7 and year 8. Secondly, that all probabilities add up to one whole. Now, one whole, when it comes to decimals, then they add up to 1. So, for example, 0.2 add 0.8 equals 1. For fractions, they add up to a whole. So, for example, if something was out of 7, then one whole would be 7 out of 7, the total, the maximum amount. E.g., 2/7 add 5/7 is 7/7. And the other thing is obviously percentages, they add up to 100%. So those are your key points so far. Final key point is that what the and or rules actually are. So the probability of something or something happening, to work that out, you add the probabilities, and the probability of something and something, you have to multiply the probabilities. So give the video a pause, write down your key points, understand them before you move on to the worked example. Okay, for our worked example then, we'll look at this question together. So, the question says, Lenny has some sweets in a bag. He has 3 blue, 5 red and 6 green. He chooses a sweet from the bag, records the colour, then replaces it. Now, part A of this question is quite straightforward. Write down the probability that Lenny chooses a red sweet. Now, don't forget, your probability can be written as fractions, decimals or percentages. In this case, we'll choose a fraction because it's easy to put whatever colour you want over the total number of sweets. So, as we can see, we've got 3 blue, 5 red and 6 green. The first thing we need to do is work out the total. So we're going to do 3, add 5, add 6, which gives you 14. So that is our total. Now we want the probability of choosing a red sweet. There are 5 red sweets, so that means the probability of choosing red is 5 out of 14. Now you need to make sure that you include it as a fraction. If you just wrote 5, that is not a probability. So the probability has to be a fraction in this case. So that one's nice and easy. Our next one is a bit trickier. This is where we start bringing in our rules. So as you can see here, write down the probability Lenny chooses a blue or green sweet. So a blue or green sweet. Now, as we wrote down in our key points, or you have to add the probabilities. So if we look at blue or green, blue, there are 3 out of 14 blue, and there are 6 out of 14 green. Because it says a blue or a green sweet, we use our or rule, which means that we add these probabilities. Now we know that when we add fractions, if the denominators are the same, you can just add the numerators and the denominator stays as it is. So 3 add 6 is 9 and 14 stays as it is. So the probability of choosing blue or green is 9 out of 14. Quite straightforward, worth 2 marks there. Now part C, we're going to use our and rule. Now the and rule tends to be less obvious. So if you read this question, work out the probability that both sweets Lenny chooses are blue. Now, you'll find with the and rule that it's not obvious in the question that it's the and rule. You have to think about it. Now, this says that both sweets are blue. So you can imagine if you were going to say that out loud, then that would mean that it's a blue sweet and another blue sweet. So that's where our and rule comes in. We've chosen 2 sweets, we want it to be blue and blue. So what happens there, according to our and or rules we wrote down in our key points, when it's something and something, you multiply the probabilities. So if we were going to multiply the probabilities of blue and blue, blue is 3 out of 14. They've put the sweet back into the bag, and we've chosen it again, and we want to know if it's blue again. So it's going to be 3 out of 14 the second time. Now, because it's and, we multiply these. Now, multiplying fractions, you know, you just do top times top, bottom times bottom. So 3 times 3 is 9, and 14 times 14 is 196. Not expecting you to know that in your head, you can use a calculator there. So that is your answer for that question, and that is the end of the worked example. So what I'd like you to do now is make sure that you've got that example all written down. So pause the video, make sure you've got all of this written down, and then we're going to move on to a your turn question. So there's the whole example with the answers. You can pause the video, write that down, and then we'll move on to your turn. Okay, so the your turn question is here. I'll try and get the whole question in one. So pause your video and get this your turn question written down. Have a go at it on your own, and then we'll go through the solutions. Okay, so you've now done this your turn question. So we're now going to do bit by bit together. So I'm going to zoom it in a bit so we can definitely see. So part A. David has some counters in a bag. The table shows the probability of choosing each colour. Complete the table. Now we know from our key points that all probabilities add up to 1, okay? So we need to work out what is left over when you add these things up. And then we'll subtract it from 1, and then you'll get what's left over for purple. So 0.3, add 0.15, add 0.25, add 0.05. Again, you can use a calculator if you wish, but if you're going to do it in your head, you can use column method, and you get 0.75 when you add all of these up. Now we know that's not the probability for purple. The probability for purple is what's left over for you to make it add up to 1. So we're going to have to do 1 minus 0.75 is 0.25. So that means the probability for purple is 0.25. That's worth 2 marks. Okay, part B. David chooses a counter from the bag, records the colour and replaces it. Write down the probability the colour David chooses is red or green. So we've got an or rule here, and we know that or means add, okay? We know that from the previous question. So, probability of red is 0.3, probability of green is 0.05, and we are going to add these together to get our probability for red or green, and you get 0.35. So there's your answer for that question. Okay, part C. David chooses another counter, okay, so we've now chosen 2 counters. Work out the probability he chooses 2 yellow. So don't forget this means yellow and yellow. So we've got our AND rule, which means that we're going to be multiplying. So the probability of yellow in the table is 0.25, and we are multiplying by the same probability, 0.25. And we're multiplying because it is the AND rule. So 0.25 times 0.25, you should have got 0.0625. Okay, you can use a calculator for that. Now, last question is the trickiest one of them all, and it says, work out the probability of both counters being green or both being purple. So both being green, we know the probability of green is 0.05, and we're timesing that because it's both green, so green and green. So when you do 0.05 times 0.05, you get 0.0025, and then we have to do the same thing for purple. So purple, the probability is 0.25 times 0.25, and you get 0.0625. Now, we're not finished because we want the probability of both green or both purple. So we also now have to use our OR rule, okay? So we've done the AND rule to work out both being green, and we've used the AND rule to work out both being purple. But if you want both green or both purple, that means that we have to add these probabilities, because the OR rule means that you add. So you get 0.0025, add 0.0625, gives you 0.065, okay? So that is your final answer. Now, I haven't said that this question was worth 3 marks because you've got that added stage of working. Okay, now that you've done that, make sure you correct your answers if you've got them wrong. And I'd now like you to go ahead and complete the AND oral practice questions, which is a Word document that has been sent to you on Teams. You can mark it using the mark scheme, and I'd like you to complete the exit card and send the photo to your teacher to mark it.